Hi, welcome to another 4AC video. This round I want to look at the quiz 5 that we have just done last week. And the question reads as follows. The sinusoidal waveforms given in figure 1.1 are those of the supply voltage and that of the current flowing in the circuits given below in 1.2. And the period t of the waveforms is 10 milliseconds. That means here t is given as 10 milliseconds. Now, first thing to note is that Vt is ahead of the current It. That means Vt reached the maximum peak value before It, right? So this is a sign of a inductive circuit, right? Now, what does the question want us to calculate? First, it wants us to calculate the angular velocity, omega, and the phase difference between these two waveforms. Next, you want us to calculate RMS value of the supply voltage and the current. And we are then required to write out the time domain expression of Vt and It. Finally, we are required to write out the supply voltage and current as phases. Right, that is part A of this quiz. And part B require us to determine the real power P, the reactive power Q, the apparent power S. Now notice that these are all just scalar quantities. And finally, the complex power S for the circuit given here. Alright, let's see how we can do that. First, what I've done is to quickly draft out some of the key information. To calculate the angular velocity, all we need to do is, we know the relationship is 2 pi f. Now, f can be calculated from this formula. From here, f is just 1 upon 10 milliseconds. That is 0.1 times 10 to the power of 3, which gives us 100 Hertz. Okay. Therefore, the angular velocity is just 2 pi f, 2 pi 100 equals to 200 pi or 628.32 radian per second. Please remember that. The next thing it wants us to determine is the phase difference. Phase difference between the voltage and the current waveform. Now, looking at the graph, for the voltage and the current, the phase difference can be written as pi over 6 minus pi over 6. That gives me 2 over 6 pi or pi over 3 radian. Let's convert that to degree is pi over 3 times 180 degrees over pi. That's equals to 60 degrees. Alright, that's for part 1. Now, next we are asked to calculate the RMS value. Now, RMS value is defined as the peak value divided by root 2. So if I look at the peak value here, the peak value is given as 160 over root 2. That gives me a value of about 113.14 volt. That's the RMS value. And for current, I pick is 2 divided by root 2. That's about 1.414 amps. Okay, and Part 3 wants us to write out the time domain expression. Now, the standard sinusoidal expression is V peak, which is 160, sine, now omega is just 628.32 t. Now, the voltage waveform is a H, so I will put plus pi over 6 V. Right? You can also write it as plus 30 degrees. Whereas for the current waveform will be 2 amps sine 628.32 t minus pi over 6 or minus 30 degrees. So that's the time domain sinusoidal expression for Vt and It. Next, we are required to write out the phasor version of these two. Now remember, phasor, we always use the RMS value. So this equals to 113.14 angle plus 30 degrees volt. And here RMS for current is 1.414 angle minus 30 degree ampere. Okay. Now next, when we look at part B, this part A, we'll look at part B. Now part B wants us to calculate the various power that is associated with this circuit. First of all, we need these two. V is 113.14 angle plus 30 degrees volt, and the current is 1.414 angle minus 30 degree ampere. Okay, for the real power P, it's just the scalar value of V times scalar value of I cosine the power factor. That means the angle between V and I. So V is 113.14 multiplied by 1.414 cosine of 60 degrees. That will give me a value of about 80 watts real power. Q, on the other hand, is just VI sine of theta V. That's 113.14, 1.414 sine 60 degrees. That gives me about 138.6 VAR. And finally, S the scalar quantity is just VI, 113.14 multiplied by 1.414. That's approximately 160 VA. Now the vector version of this is just V vector times the conjugate of I, which means that I make use of this 113.14 angle plus 30 degrees, but the conjugate of I will use 1.414, but the angle I mirror it, instead of negative become positive. VA. That gives me about 160 angle 60 degrees VA. Right, so there you are. These are all the values. In fact, if you want to, we can draw the power triangle. Power triangle is S, P, and Q. This is the angle 60 degrees. Where this is about 160 VA. This is Q. Q is about 138.6 VAR, and P is about 80 volts. Alright, so that's all for this quiz, and hope this video has been useful to you.